pattern in elementary mathematics. Our stability is that balance, and wisdom lies in the masterful administration of the unforeseen. All bridges the statement of beauty. Let us consider patterns for a moment from the lowest possible point of view, that is, for a person who simply wants to pass an examination. The most important question for the examinee is the character of the examiner. What are the examiner's interests? Yes. What qualities is he trying to test in the examinee? Some examiners seem mainly increased in the ability of their student to carry out routine operations. Does the student know his multiplication tables? Can he use the logarithms? Can he use any one of the hundreds of other stock methods? Doubtless, it is necessary to test the student's knowledge of the routine processes, but ever since being a boy, I have classified such tests as dull examinations. They are very popular with poor teachers, since the teacher knows he has merely to drill his class on exercise 1 to 50. As the examiner wish to encourage the more enterprising teachers, the teachers who are trying to convey not merely facts but the feel of the subject. They wish to test the enterprise, the imagination, the initiative of the students. And so they seek out problems which call for these qualities. Some teachers feel this to be unfair. They think that pupils cannot be prepared for unpredictable examinations. But this is not true. Is a battle predictable? Is it therefore impossible to train military leaders? The training of the officers is based, or should be, partly on those general principles which are common to all battles, and partly in developing initiative. The officer is placed in a variety of the unforeseen situation in which he has to improvise. Yes. Exactly the same type of approach is possible in the peaceful training of the mathematicians, and examination and a battle have much in common. An examination paper may contain both routine and problem questions. How is a student to know which is which? They need not look very different. Take for example the simultaneous equation below. Yes. 127x plus 341y equal 274. 218ax plus 73y equal 111. There is a routine method for solving such equations. If we multiply the first equation by 73, the second equation by 341, and subtract the first result from the second, we find that x must be 17,849 over 65,067. This answer does not simplify. There can therefore be no way of avoiding arithmetical calculations. An examiner who set such a question could merely be interested in seeing whether the student knew the routine method and had the persistence and accuracy to carry through the arithmetic. I assume the exact answer as a fraction is wanted. If only an approximate answer is required, the labor can of course be reduced. For example, by using a simple rule. The value of y is equally complicated. For contrast, consider the simultaneous equation of 6,751x plus 3,249y equal 26,751. 3,249x plus 6,751y equal 23,249. 249. The numbers here are larger, but the problem is much easier one. The problem is not intended to test routine work. There is a very simple way into it if the examinee can find how. What clues are there to suggest that this question calls for an imaginative attack? There are certain clues in the choice of the numbers, but the most striking and significant clue is the pattern. Oh yeah, look at the picture. Significant clues is the pattern star or, which appears on the left-hand side of the equations. Yes. These left-hand sides have in fact an algebraic form: ax plus by equal 1, bx plus ay equal 2. Roman 1, Roman 2. Yes. In looking at these expressions, I find myself reasoning in the following somewhat idiotic fashion. If we were to christen our unknowns x and y, so that x was called y and y was called x, the expression Roman 1 would become Roman 2, and the expression Roman 2 would become Roman 1. So the expression 1 and 2 are just as good as each other. Wow. It would therefore be unfair to do anything to Roman 1 that we do not do to Roman 2. Whatever steps we take ought to treat Roman 1 and Roman 2 alike. What steps are there of this kind? The obvious step is to add Roman 1 and Roman 2. This is a perfectly symmetrical operations. Are there any other symmetrical operations that we could do? We could of course multiply Roman 1 and Roman 2 together, but that would be helpful. But that would not be helpful towards solving the equations. We want an operation of the form m Roman 1 plus n Roman 2. At first sight, it seemed that to be fair, we must take m equal n. Otherwise, whichever expression gets the bigger number, the other expression can complain of injustice. There is, however, a possible solution. The equation p equal q is certainly symmetrical as between p and q, but if we try to write this equation with all the non-zero terms on one side, we obtain p minus q equals 0. This appears unsymmetrical. We have taken an arbitrary choice, and in deciding to assign the plus sign to p and the minus sign to q. But if we had taken other decision, we should have written q minus p equals 0, which again expressed p equal q accordingly, although the expression p minus q is unsymmetrical. We need not fear we are sinning against symmetry. If given two expressions of the equal status, we subtract one of them from the other. Returning to our original problem, we now have two operations that seems to have symmetry appropriate to the problem. To add and to subtract the equation given, carrying out these operations, we find 10,000x plus 10,000y equal 50,000. 3,502x minus 3,502y equal 3,502. That is x plus y equal 5 and x minus y equal 1, from which x equal 3, y equal 2. Children can find real pleasure in the experience of solving such a problem. Not everyone will follow the somewhat fanciful path I have just described, but anyone who solves this problem, other than by sheer calculations, will in some way be responding to the patterns of the equations. The conquest of the problem depends on the sensitiveness to pattern. This combination of the military and military, and an artistic aspect is perhaps not realized to such an extent in any activity outside mathematics. Ha ha ha. In adult program, nature is examiner. In adult programs, nature is the examiner. And here again, it is of the utmost importance to determine whether any particular problem involves a routine slog or whether it has some special feature that will make possible a simpler solution. Many practical problems, of course, can only be solved by routine methods. They lack pattern. This is particularly so if there is an element of the randomness in them. In surviving, for example, a host of geological and historical causes have interacted to determine the position of the towns and mountains between them. One does not expect any elegant relations between the distance on the map. Calculation is inevitable. On the other hand, in a fundamental scientific program, the structure of the atom of the universe, one does rightly or wrongly expect to find an underlying simplicity. The basic theories of physics usually possesses a mathematical elegance. Their applications to complex situations, needless to say, may not.